Unit 12, A Planet Hunters. A. It took humans thousands of years to explore our own planet and centuries to comprehend our neighboring planets. Nowadays, though, new worlds are being discovered every week. B. To date, astronomers have identified more than 3,900 exoplanets, worlds orbiting stars other than the Sun. There's a hot Saturn 260 light years from Earth that orbits its parent star so rapidly that a year there lasts less than 3 days. Circling another star 150 light years out is a hot Jupiter whose upper atmosphere is being blown away by the star's solar winds. Astronomers have also found 5 planets orbiting a pulsar, the remains of a once mighty star shrunk into an atomic city-sized nucleus that spins. Some worlds have fallen into their suns. Others have been thrown out of their systems to become floaters that wander in eternal darkness. C. Among all these, astronomers are eager to find a hint of the familiar planets that resemble Earth. That is, they are looking for planets that orbit their stars at just the right distance, neither too hot nor too cold to support life. However, we have not yet found planets that are quite like our own. To see a planet as small and dim as ours amid the glare of its star is like trying to see a firefly in a fireworks display. Yet by pushing technology to the limits, astronomers are rapidly approaching the day when they can find another Earth. Hunting for other Earths? D. The most direct approach to finding a planet is to take a picture of it with a telescope. Astronomers have detected more than half of the confirmed exoplanets this way. All of them are big and bright and conveniently far away from their stars. E. A more effective way to detect an exoplanet, though, is to use a method known as the Doppler technique. This involves analyzing starlight for evidence that the star's movement is affected by the gravitational pull of a planet. In recent years, astronomers have refined the technique. They can now tell when a planet is pulling its star by only 1 meter a second, about human walking speed. That's enough to detect a giant planet in a big orbit, or a small planet if it's close to its star. F. Another approach is to watch a star for a slight dip in its brightness. This occurs when an orbiting planet passes in front of the star and blocks part of its light. At most, 1/10 of all planetary systems are oriented so that these mini eclipses, called transits, are visible from Earth. So, astronomers have to monitor a lot of stars to capture just a few transits. G. The dream of astronomers is to discover a rocky planet roughly the size of Earth, orbiting in a habitable zone, that is, not so close to a star that the planet's water has boiled away, but not so far out that it is frozen into ice. If they succeed, they will have found what biologists believe could be a promising abode for life. H. The best places to look may be dwarf stars, which are smaller than the Sun. Dwarf stars are plentiful. 7 of the 10 stars nearest to Earth are dwarf stars. They also provide a steady supply of sunlight to any life-bearing planets within their habitable zone. I. Additionally, dwarf stars are dim, so the habitable zone lies closer in. If the planet is closer to the star, it's easier for astronomers to detect a transit observation. A close-in planet also has a stronger pull on its star. That makes it easier to detect with the Doppler method. Indeed, one of the most promising planets yet found, the super-Earth Gliese 581d, orbits in the habitable zone of a red dwarf star, only 1/3 the mass of the Sun. Life on other worlds. J. If an Earth-like planet is found within a star's habitable zone, a space telescope could be used to look for signs of life. Most likely, scientists will examine the light coming from the planet for possible indications of past or present life, such as atmospheric methane and oxygen. They might also look for the red edge produced when chlorophyll-containing plants reflect red light. K. Directly detecting and analyzing the planet's own light will not be easy. Its light might be just 1/10,000,000th the light of the stars. But when a planet transits, starlight shining through the atmosphere could reveal clues to its composition that a space telescope might be able to detect. L. The challenge facing scientists is not just having to perform a chemical analysis of planets they cannot see. They must also keep in mind that life there may be very different from life here at home. The lack of the red edge from an exoplanet, for instance, does not exclude the possibility of life. Life thrived on Earth for billions of years before land plants appeared and populated the continents. The problem is that biological evolution is very unpredictable. It is possible that life originated on an Earth-like planet at the same time it did here, but life on that planet today would almost certainly be very different. As the biologist Jacques Monod once commented, life evolves not only through necessity, but also through chance, the unpredictable intervention of countless accidents. And chance has played a role many times in our own planet's history. The most dramatic examples are the mass extinctions that wiped out millions of species and created room for new life forms to evolve. Some of these accidents appear to have been caused by asteroids or comets colliding with Earth. An impact 66 million years ago, for instance, helped kill off the dinosaurs and opened up opportunities for the distant ancestors of human beings. Hence, scientists look not just for exoplanets identical to modern Earth, but for planets resembling the Earth as it used to be, or that it might have been.
It was not easy for earlier pioneers to undertake explorations of the ocean floors, map the far side of the moon, or find evidence of oceans beneath the frozen surfaces of Jupiter's moons. Neither will it be easy to find life on the planets of other stars. But we have now reason to believe that billions of such planets exist. They hold the promise of expanding not only the scope of human knowledge, but also the richness of the human imagination.